The fourth type of graph is the velocity various position graph. The first thing to do is to write down the equations for each segment. In this example, the first segment is v equal 0.08 second, and the second segment is the v equal minus 0.80 second plus 16. Let's find the acceleration of this object. For equations asking for acceleration from velocity vs position graph, the only thing you need to remember is that as ds equal v dv. We will focus on the first segment. First step is to take the derivative of the velocity equation. So dv over ds equal 0.08. Now we need to manipulate this to write it as dv equal 0.08 ds. That much the trick these types of problem. Then it is just substituting this into our equation. So ds equal vd, the v part is 0.08 s, the dv part is 0.08 ds. So we have ds equal 0.08 s multiplied by 0.08 ds. Cancel out the ds from the both side, and you have an acceleration equation. A is equal to 0.00 for 64 s. You didn't even have to take an integral. It is the same for the second segment. Take the derivative of the velocity equation. We get ds dv over ds is equal to minus 0.08. Manipulate it is and write it as dv minus 0.0 ds. Substitute this into our ads equal vdv equation. We have ads equal 0.08 plus 16 0.0 ds. Simplify to get your acceleration equation. Now you can plot the acceleration equation or find the acceleration value at a specific time. The other problem they might ask for it to draw a position vs time graph for the velocity from the velocity vs position graph. Let's look at this new example where we have two equations given to us. For this, remember that velocity equal ds over dt. We need to isolate dt. So we can write it as dt equal ds over v. Now we need to have time on the left side. So we need to integrate. In other words, we need to change dt to t. And way to do that is to integrate. So we have to the following integral. All we did was simplify, substitute our velocity equation to v. The lower bounds are 0 seconds. And the displacement is 0 meter. Don't get confused here. It is simply simplify 1 over the velocity equation. Solve the integral and you will have an equation for time. Since we need it to be equation for displacement, we need to isolate our equation for s instead. So changing it gives us an equation for displacement with respect to time. The next step, as with other problems where we took the integral, is to find the displacement value at the time when the new segment starts. So we need to substitute 100 meter and solve for t. We get a time value of 10 seconds. Now we can write the integral for the next segment as before. The lower bounds are 10 seconds and 100 meters. Solve the integral and isolate for s, and you will get the displacement equation for the last segment.